Hello everyone, and welcome to episode 1 of a new 2D and 3D physics engine development series. Follow me as I create two of the biggest projects I will have on my portfolio in my future. First off, let me go over a little bit of my journey so far. I've been working on video games for a good part of the last 6 months now. I have many projects under my belt, mostly 2D, with a few 3D projects as well. My ultimate goal is to develop physics engines for video games after I leave university. So, two major projects I want to showcase on my resume are a solid 2D and 3D engine. So, over the next 3 years, in my free time, I'll be putting work towards my 2D and 3D physics engines. The goal is to make something flexible, something that I can use the same engine to make different types of games in. Next, I want this engine to have user-friendly elements to it. I want any random developer to be able to pick up these engines and either supplement the code with, for example, UI elements, or make their own games entirely out of it as well. Finally, I want to use actual physics calculations and systems in this program. So that includes things like gravity, buoyancy, spring elements, etc. I want features like particle physics, mass aggregate physics, rigid body physics, collision detection, contact physics, and more. So the 2D physics engine is going to be the main focus. And what I learned in the 2D physics engine, I would like to bring into 3D as well. These two projects are going to be incredibly challenging. That's why I'm giving myself 3 years. I'm going to have to rebuild the projects multiple times, do different projects of different physics systems in order to bring it into the main project. It's going to take a very, very long time. This is why I'm giving myself 3 years. The goals for episode 1. I would like to set up the environment, create the entity class, create the ability to spawn shapes in the environment, create the physics class, and have the physics class interact with the entity class. Let's take a look at the code now. So I have already completed all of my goals for episode 1, and I actually stream all the progress that I make. So if you ever want to pop in and say hello, you're always welcome. First goal. We want to set up the project environment. We're using the library Raylib for this. We have been using Raylib for just about all of our C++ game programs for the past 6 months. We're creating the screen width and screen height, 1080 by 720. We're initializing the window, setting the target frames per second, and then we have our main while loop right here. So, step 1 done. Next up, we created the entity class, and the entity class is going to control all of our characters. So, when we create our entities, we have the name of the entity, the position in space, the size of the entity, the weight of the entity, and the color. And we're able to draw circles and rectangles for now. Soon we'll be able to draw triangles. So next up is the physics class. And in the physics class, so far we are applying gravity to our entities. Let's take a look at the program. So this is what the program looks like for now. We have a method to prevent the shapes from leaving the screen. And we have a method to apply gravity to them. So the shapes drop. They drop at a consistent time per shape. They have an initial velocity, a terminal velocity, and it gradually increases in velocity as it drops. Now, for anybody who wants to see the code, this section is for you. Let's take a look at our entity. In our constructor, we're taking in a name, a position, a size, a weight, and a color value. We use those values to draw our circles and draw our rectangles. Here, using the position and the size. This works for rectangles and circles so far. We're taking size.x for the radius of the circle. Next up, we have left-click controls for each. And so we're using a drag offset value that we set as we move. And if we're dragging, we're applying the new entity position, subtracting the drag offset, and then setting a position through a function that we created earlier. And then we set the position through this function that we have created. The same logic applies for the circles, except we use square root instead. Next up, we have clamp logic to prevent the shapes from leaving the screen. Adding the screen width, screen height, the values. And now to the physics. So in order to interact between the entities and the physics, we're using a pointer of entities. And when we construct the physics, we're adding that pointer to the physics. This is how we're applying gravity to the entities. We're using a for loop. If the entity is not on the ground, and if the entity's velocity is 0, then we're applying initial velocity to the entity. Then we're incrementing gravity. And if the entity is greater than terminal velocity, then we're setting it to terminal velocity to max out how fast a shape can move. Otherwise, the initial velocity will equal 0 if the entity is on the ground. And then we're incrementing the position y of the entity, multiplying it by delta time. Any physics function that we create are going to be added to the update function of physics and then applied to our main loop. That's it for episode 1. We've created the foundation for the project, we've spawned shapes into the world, and we've applied gravity. In episode 2, we're going to dive into collision detection and more physics. Thank you for watching. Leave a like, leave a comment, help the algorithm out. Thank you, and take care.